Yeah, so telemetry systems exist all over the world in all kinds of systems. And abstractly, this is just when you want to automatically measure and wirelessly transmit data from remote sources. So in the CHT, that means that we want to automatically take measurements as the app is being used, and then send the data of those measurements to the server whenever users sync. So we know that we are when we sync, we're sending back the data of the form and the health data in the forms that we've filled in, but we also are sending information about the performance of the app and a bunch of details in the background. And so the data from our telemetry system is exposed to users through Postgres, and this creates a feedback loop. So yeah, there's telemetry systems all over the world. Kind of the most famous ones, or like the easiest ones to make analogies with, sometimes are like rocket ships. And everyone like sees the image of a rocket ship. And then there's like ground control during takeoff or something, and they're monitoring, all these different healthy parts of the system, making sure that things are going okay. So there's lots of these people in the rocket ship ground control, and so what would all the people be doing? So there are what we can monitor is things like remote monitoring, so system health, system performance. So are things moving fast enough for users? Are things behaving? Are people having problems with the app? But basically, in public health, there's a lot of sort of literature about how to monitor public apps, and so sort of maturity models and things like this. And a lot of it is based around the idea of, or the building blocks of it is this concept of nascent monitoring. And so that's saying, if you're going to make a public health intervention, is the public health intervention doing the thing that you're saying it's doing? Telemetry is very useful for this nascent level of monitoring. So, and the next thing we can do with it is understanding. So we can learn what kind of devices our users have installed, or what kind of devices they're using to access the system. We can learn about users' behavior, like what features they're using or what features they're not using. We can release training programs and things like this in order to sort of like change and monitor user behavior. And we can make comparisons. So on CHT 4, this is how fast this experience was, and on CHT 4.3, this is how fast it was. And so we can watch we can confirm expectations about like, oh, well, we thought this was getting faster. And then indeed it did get faster in the wild. And then the last type of scenario that we'll talk through is informed technical support. And so telemetry systems allow you to make proactive, informed technical support. And we'll go through some examples of this, but when you are talking to a user, you could ask them for all their details, like what type of phone do you have, and how old's your installation, how many documents do you have. You can ask users to report these details, or you can measure it remotely, and you can like pull up that information about a user quickly and easily. And a lot of the time it will be more accurate, and it will allow you to make the right steps quicker in order to support users, or even to proactively reach out to users who need help, who haven't yet come to you for assistance. You can fix the problems that they're facing. So.
Cool. Thanks, Ken. I'm sorry, I didn't get the dress code memo early enough on this one. Ken had his headlight on here.
Sorry, that's embarrassing. I can't see myself.
No worries.
Thanks.
Hi, everyone. My name is Michael Cohn. I'm a product manager at Medic. And yeah, so as Ken just mentioned, we have telemetry so we can understand more about things like system health and performance, device configuration, and different user behaviors. Just to kind of go one step further and talk a little bit more about what we're looking at. Here's a high-level look at the types of things that we measure. So again, just from a high level, we look at things like, or we can measure things like startup. How long does it take the app to load? How often is it restarting? You know, we can look at things like how often and where is the app crashing, or we can look at things like replication. How frequently do users try to replicate? How long is it taking for replication to complete? And again, are there failures? For things like forms, when CHWs are filling out forms, we can see how long does it take, for example, how long does it take to load a form? Or when you click the save button, how long does it take for the app to convert it into a JSON doc? How frequently are users editing forms after they've submitted them? You know, how frequently will does a CHW actually start filling out a form but cancel out of it before they complete it? So they're like abandoning the form. So we can see those types of things. We can also see information about CHT features, just whether or not CHWs are even using certain features in the app. We have a couple of examples of those a little bit later. We can, as Ken had mentioned about different types of device configuration, we can see that in telemetry as well. We can also see what language they're using in the app. If there's multiple languages, how many documents are actually on the device. We can also see things about geolocation. So this is more about the behavior and kind of aggregate information about these things. So, you know, when was geolocation enabled or disabled, or what were some of the reasons why it failed to be collected? And for each one of these, we can also see some metadata around the user's, the CHW's device. So for example, like what version of the app that the CHW is actually using, have they actually upgraded yet? What version of Android are they on? Again, you know, how many docks, how much free storage there are in the device. So we can see all those types of things. And for each of these types of activities and things that we record in telemetry, we have a bunch of different measurements, which we have highlighted on the right side of the screen there. So I'll just use like successful replication as an example. So we can see in telemetry a count of the number of times that replication was attempted and successful on a given day for a specific CHW. We record the min, which represents out of all the times that the CHW tried to, the number of times that the CHW successfully replicated. What was the fastest time that it took the system to perform that replication? We also capture the max, which is the opposite. What is the slowest time that it took replication to successfully complete on that day for that specific CHW? The sum represents the total time spent replicating across all attempts successful on that given day. So we capture all of that. We also, in telemetry, you'll also see the sum square, which represents the sum of the squares, which can often be used to understand the variability of data, but the way it's currently implemented right now is it's not actually useful. So you can basically ignore that for now. But using the sum, the min, the max, and count for all of these different types of measurements, you can learn quite a bit. Yeah, I wanted to talk through a couple of examples From how myself as a product manager, what I love about some of the telemetry that we collect is it allows me to understand how certain features that we've developed are being used. And um, so, for example, in 4.2, we released a feature that helps reduce training costs and makes it easier to do things like refresher training because it's all available within a CHW's app. But before releasing this feature, we worked with a project to deploy these training cards as a feature release. And we monitored the usage very closely so we could understand how CHWs were interacting with these training cards. So with telemetry, we could see, for example, how many CHWs had actually seen the training cards when they opened their app. We could see how long they spent reviewing the training cards, and as well as how many times they actually like canceled out of them. And yeah, and how many times they actually completed the training. So this alone does not necessarily tell us if the training itself was effective, but what it does is it helps us get a better understanding of how CHWs interacted with the training cards themselves. So one of the things that we were particularly interested in seeing was, for example, how often CHWs were being presented with the training cards, but did not complete the training. So the training cards popped up when they opened their app, but they canceled out of them before completing them. We also wanted to see, for example, how long CHWs were actually spending looking at the training. More on the low end than the high end, because we know that things can happen while you have while you have the app in front of you. Somebody might come up and start talking or whatever. But one of the things that we wanted to see was, for example, if they completed 3 or 4 pages of training cards in 2 seconds, then it's pretty likely they were just skipping through the training cards and not actually reading them. So based on these types of insights, we can focus our research and interviews on better understanding those specific interactions. So we can go interview users to basically gauge what their experience was. But this data helps us know where we should be asking questions. So, for example, in these training cards, the 2 main things that we measured in telemetry was render and submit. So render is basically how many times did the training cards pop up for that particular CHW on a given day, and submit is how many times did they actually complete the training and submit the training cards. Next slide. Cool. So another example of how we are using telemetry data to monitor new features is with the barcode scanning feature. Just like the training cards, we released this as a feature release. We worked with a project to deploy it, and we kept a close eye on the data to see how CHWs were engaging with it. So this list on the right illustrates the types of things that we were able to monitor. Open, basically, so you can kind of see that little the QR code looking thing next to the hourglass, next to the magnifying glass. So basically, whenever a user taps on that little icon, we would record that in telemetry, and we would so we would know how many times people actually tapped on that little icon. When you do tap on that icon, it opens up a screen where you can take a picture of a barcode. So we also measure that. How many times had a CHW actually taken a picture of a barcode? That's the scan data point. Whether or not they triggered an actual search. We can also know, for example, if the not detected means they scanned something that was not recognizable, for example. The app did not recognize, couldn't detect the barcode there. Failure, we can see if there's any particular system failure when the barcode detector tried to get the code from the image but couldn't. if the feature is not supported, they tried it, but the actual feature is not supported on that device. And we can also see, if the CHW used the manual search method instead of the barcode. So this is all real great data for us to help understand usage. It doesn't necessarily give us answers, but it helps us know which types of questions we should be asking. For example, if there are users that never even tapped on the barcode icon, even though it was deployed, we can try to understand if maybe there was an oversight in communication of the new feature, or if there were some, issues with training or something like that. If one user is having many failures on their device, perhaps their device is out of date, and it doesn't support, the actual hardware doesn't support barcode scanning. If a lot of people were opening the scan feature but never actually searching, we need to figure out why. So like I said, in most cases, this type of data doesn't necessarily give us specific answers, but it helps us understand what questions we should be diving into and understanding more.
Another use for telemetry that we talked about was monitoring crashes or errors that are happening on the device. And this is a pretty important use case to just understand and make sure that the app is doing what you say it's doing. So this is a graph that we have for some monitoring dashboards, and basically you can see how many crashes are happening per day across all of the devices for an entire project. And we sort of have two categories. One is called an automatic. So this means that a crash or an error has happened on the device and we've sent details about that error. And the other category here is a manual error. So that means that the user has gone to the hamburger, the dropdown, and said, report a bug. And so there's some sort of information. They've sent a message to their system admins kind of looking for help or outreach. And so we can read that information and monitor when that's happening. Oh yeah, I'll just say one more thing about errors. Errors fall into two categories. They're either a CHT core error or a app error. And sort of, it's a little bit difficult to sort of dispatch who should be responding to these things, but looking at error rates is a pretty important thing. So form completions, Michael hinted at this one a little bit already, but here we have a household survey, and 631 times it was opened but not completed, and 868 times it was opened and completed, and so its completion rate is around 34%. And then so that might indicate that this household survey form has some kind of problem. Why would a user open this and so frequently? That this 34 number seems incorrect, but why would a user open this and abandon the form so frequently? It's possible that there's something that we should look at in the design of this form. And so when we're doing sort of data-driven initiatives or data-driven iterations on app designs, this is a really important number to look at. And so, healthy forms probably get abandoned less than 10% of the time, but some of these forms are being abandoned very frequently and probably indicate some sort of design issue or even a technical issue. Sometimes a form can't be completed. There's an error or something and the user can't get past it. Here's an example of replication health. And so this is kind of an extreme example, but we can look at the rate of denied replications. Denied replications happen, for example, if you move a contact before they've synced their data, and now the unsynced data cannot be replicated to the server. And so this allows us to monitor the incidence of sort of documents that are going to remain on that user's phone and not ever make it to the server. And so here, probably someone just did some sort of contact move or some sort of maintenance to user accounts prematurely when the user wasn't ready for maintenance. And we've seen a big spike in denied documents and data loss. And so hopefully we can now use this, program administrators could use this to train their devs or train their system administrators in order to like make sure that they're syncing data for users before they move the accounts. And this is just a story from a Nepal technical support. But basically we were having a performance problem with a form. And it was related to geolocation. So it was taking sometimes over 10 minutes for the form to load and save. And so what we said to the entire program was that we were going to disable geolocation services. We sent out instructions to all users on how to disable geolocation services. Problems for complaining about the issue. Through telemetry, well, we spent a lot of time investigating what else could be causing this problem, and we couldn't come up with any answers. And through telemetry, we were able to demonstrate that users had not disabled geolocation services. And we could look one by one as to which users had and which users had not disabled geolocation services. And we were able to follow up with them one at a time in order to make sure that they disabled the services and that the performance of the app was back to a usable state. So this is just an example of sort of targeted technical support where we're doing outreach, it's proactive, and it's technically informed through telemetry. We're going to get to a demo in just a second here. Sure. And that demo is going to be using Postgres. Postgres is our primary interface to telemetry data and how it's sort of used and surfaced to other kinds of sort of validate or sort of visibility layers or visibility tools. You can plug it into any sort of visualization tool that you like. And so I'm just going to quickly talk about the interfaces that I'm going to be demoing in Postgres.
Thank you, Ken. I know it's going to be exciting to look at demo, but I see there's a couple of questions. Maybe you can just address them quickly and then move towards demo.
My question is on form completion as one of the use cases. And I was just curious if the completion rates could be filtered down to a community health worker, because in the context of supervision, we see a request where supervisors want to be able to tell how to provide targeted support to community health workers who may be struggling with task completion or who may simply be spending a lot of time completing forms. And we're looking for a way to visualize this on the dashboards that supervisors see so that they can use that as a basis for targeted supervision or support. So I'm curious if the visual that we just saw allows to be filtered right down to a community health worker. Thanks.
Yeah, you can segment the data by username and by, yeah, actually I'm going to demo the form completion metric in just a second. And so I'll just like show you how to segment it by users.
I think, thanks. It's about the location services. Does that mean that every user must disable the location services? Is that mandatory? Is that what you mean?
Yeah, the geolocation story is maybe a little confusing. This is a bug. This was a bug in CHT core, and it only happened on a sort of subset of devices, but those devices were being used a lot for this project. Basically, the leaders of that project just made a decision to turn off geolocation for a time. I think eventually we got a CHT core patch and released it. But yeah, this it's not like a desired state to be in a situation where geolocation is off for all users. And I don't think that there are known problems today with geolocation. But correct me if anyone knows of any.
My question was in relation to what Sanjay had asked, but to ask him if the geometry location services are disabled, how then can you be able to tell with community health workers are facing challenges in a particular region? How can you be able to assist them? Which households are being affected? And in terms of training, how can you be able to now advance trainings to these CHWs to enable them perform better in the field? Thank you.
Yeah, I mean, geolocation is one way to know where CHWs are and to group them together. Another way might be that your hierarchy is configured in a way that lets you do that. And so if your CHWs are together, you know, if you have like a county and a sub-county, and within a sub-county you have some sort of other geographic region, you would still be able to sort of group them by that. And typically you also don't need live geolocation data on every report in order to kind of get a rough idea of where a CHW is. You could still just look for the average geolocation data for a CHW and then kind of use that in order to make a heat map or something like that. Again, we didn't turn off geolocation on because we wanted to or because we recommended. It was sort of like a crisis and an incident response. But yeah, great question about sort of how to target that. I think there still are some means that you could use there.
My question is basically if we are also collecting the amount of time taken to complete a form, which then could be correlated with the data that you're collecting on completed forms. Maybe there could be a hypothesis that the lesser the forms that are completed, the longer it takes for community health worker to complete that form and vice versa.
Yeah, totally.
Then
I'll put that in the demo too. I was gonna demo this form completion stuff, so I'll just like add the metric on how to do how long the forms are taking also.
Great. So the other interesting thing there is that when you train a community health worker for the first time and they start using the app, of course, the dependency on the app is very high. They have to go like question after question, but we expect that the more adept they become or more skilled they become on using the app, so the faster they are in completing some of these forms, and probably the better quality of engagement they have with the patient as opposed or the client, as opposed to when they were just reading a question, getting an answer, and updating the answer. So I think it will be interesting to see how that changes over time in terms of just maybe over the next 3 months after training. How fast are you able to submit the forms, as an indicator that you're becoming a more proficient user of the app? Wasn't really a question, but an interesting use case.
Yeah, you would definitely be able to see that in the data. If that hypothesis is true, you could confirm or you could test that. So next slide, I'm just going to talk about the interfaces that we use in telemetry. So basically Couch to PG makes some views for you that allows it to be quick and easy to work with telemetry. The first one is called Telemetry Metrics. And for this, we're going to have one row per user, per device, per metric, per day. And that's probably a mouthful to think about. But it's going to be a lot of rows, but for every metric that we measure, for every user that uses the app, for every day that they use it, and for every device that they log in on, there is going to be a row of data. And then telemetry devices, you're going to have one row of data per user per device. And so this can give us a list of basically all of the devices, all of the unique devices that a user uses. All right, and then use view telemetry. This is a deprecated view, which we don't actually recommend using. It's pretty confusing. And then the last one I'll talk about is use view feedbacks. This is one row per unhandled error or per manually submitted error from a user. So every time that the user reports a bug or has an error on their device, you're going to see a row. So with that in mind, that's going to just give some context for this demo. So we can proceed with the demo now. Can you see this?
Yep.
All right. So yeah, I'm using a set of data for a project. I've changed sort of usernames and stuff, but it is real data. There is no personal health information in telemetry, and this app isn't online. It's not publicly accessible, but it is going to give us the ability to sort of like take a look at some interesting data that's easily available. So here I'm going to look at this first view that I talked about, the telemetry metrics view. And so I'm just going to look at a single document to start. And I just picked this at random. But, you know, here you can say for one day, for one user, and for one device, here is all of the different metrics that were measured for that on that device. And here are the values. And Michael talked about these values a little bit. We've got the smallest value, the biggest value, the sum of all the values that count, and then this variance metric. So, so for example, if we were to look at, this is in Keto, that's our system for rendering forms. Contacts, that is, this form was loaded from the contacts page. Drug dispensing, that means this is a drug dispensing form. That's the name of the form that was filled. Add, we are creating this form, we're not editing it. And save, this is how long it took to save. So once they clicked save, how long did it take before the actual report was created? We can see that this form was saved 12 times by this user on this day. The fastest time was 800 milliseconds and the slowest time was 16 seconds. And that's the general idea of this data. And so I want to look here at the count of saves, and I'm going to compare it to the count of render events. And if I do that, I'm going to be able to see our form completion rate. So here I'm going to just say, I'm going to just look at metrics that are, you know, in Keto just to start. And so you can see there's in Keto tasks and forms and all this stuff. And I'm going to select, I think it's split part metric by this 3. This is just going to get a little weird for anyone who's not that technical. But basically, I'm taking this metric name, I'm splitting it up by the colon, and I'm going to take the 4th value. The 3rd value. So in this case, a vital. So what I want to see is the name of the form that this is happening to. Anyway, just ignore that if you're not that technical. And then I'm just going to sum the count. And I'm going to filter where the metric is like save. And then I'm going to call this save count. And so oh, sorry. Okay, so now I can see that the adherence form has been saved 12 times. The appointments form has been saved 12 times. The drug dispensing form has been saved 24 times by this user on this day on this device. And then I'm going to do the render count. And now by render. And so now I can see that, you know, we saved 24 times, but we loaded it 27 times. So our completion rate's probably in the 90% here. But I also, everything else looks like it was 100% completion. So I'm just going to get rid of this now. And so now I'm going to look at the data for all users. Yeah, I can see that Yeah, and so now I have this data for all users. And then what else did we want to do? We wanted to do the username, and I'll group by that also. And so now we have the answer to, I believe it was Brian's question on, I want to see this data on form completion per user. So now the adherence form, this is per user per form. And so now the adherence form by this user King was opened 197 times and saved 195 times. So he's doing pretty well. And then the last one was, I think it was from Simon. We're going to sum the sum and divide it by the sum of the count, and that'll give us a mean. And I'm going to filter that by, I forget what it's called, but it's like, it's got the word edit in it. I hope this works. I'm really sorry if this doesn't, but it'll give you the idea. So the mean edit time, for this user, it's 46 seconds. For here, it's 37 seconds, a minute and a half. Here's 3 minutes. So we could like go down here and look at it. We could also look at our max time or whatever we want here. And so this is just a quick idea of how you can get some of those metrics that we asked for in chat. Any questions about this demo? I can do all the cool stuff that's needed to just divide this number by this number, but I kind of figure like most of y'all can do that. I could also just show, period start is more recent than now minus something like 60 days. And so that would just like segment it to looking at 2 months worth of data, stuff like that. All right, I'm just going to pause for questions, but you can also just ask questions at any time. Yeah, and for the more tech savvy people, you can import this data into like visualization tools like Power BI or whatever you can. There's all kinds of AI tools that will just like automatically make visualizations for you, or that will kind of create drag and drop experiences for you. I'm just going kind of deep into the data just to kind of give people an idea of what this looks like. So yeah, the next thing I'm going to do here is just look at this other view called telemetry devices. And so I'm going to group by username, and I'm going to look at username and count. And so here this is saying how many users do we have and how many devices have each of them used. So these users have logged in from 2 devices, 7 devices, things like this. This is basically showing how many initial replications have they done throughout the entire life of their use of the app. And so I'm just gonna like do a quick thing here, which is I'm just gonna look at what Chrome version are they using. And so I've got a user agent. This is the user agent that is used to connect. I'm just going to parse it, and using this regex, I'm going to pull out the Chrome version. And so now I can say that 6 of these devices are on Chrome 16, and all of them are on version 111 or latest, which is everyone has on a supported version of Chrome, and things are looking great. So this is just a quick example of how to look at sort of device level data for across users. That kind of concludes the demos. If anyone has any questions, I'm happy to do stuff. It's kind of hard to just pull out metrics exactly as requested, but there's a lot of metrics online in the CHT data ingest repository. It has a lot of telemetry metrics that we use for app monitoring dashboards. there are lots of sort of similar systems in CHT that provide telemetry-like functionality, and I just want to be clear that's kind of not exactly what we're talking about today. But so we are talking about the sort of telemetry system or the feedback system within the CHT. There is also task documents. Task documents exist for really no reason other than to let you know how users have interacted with the very complicated feature that is tasks. And so they're sort of an elaborate form of telemetry. And there's also a lot of sort of hidden information inside of the reports that people sync. So there are sort of similar systems inside of the CHT, but that's not exactly what I'm talking about. Also, from the question that people answered when joining this webinar, we just wanted to be clear that telemetry is not the data that's in these forms that get submitted by users. It's not the health information. It's not sort of CHT's audit log. It's not CHT's sort of server-side logging information. There is a dedicated document called a telemetry document and a feedback document, and that's what we're talking about here today. So what are these telemetry documents and where do they come from? This is something that I see people confuse a lot. We're going to try to stay high level, but I think it is important to have some level of understanding around this. And so these telemetry documents contain the data that we just looked at. We looked at one telemetry document for one user for one device, and it has just a list of metrics, all the things that they did that day. And so it all starts with the user interacting with the CHT. So they interact with the CHT, and while they're doing that, we're recording some data. That data gets recorded on the device. So this teal level is the device. And we're just like recording it in the background. And then at the end of the day, that telemetry data is rolled up and created. And now we have a telemetry document. Until now, we did not have a telemetry document. But now, the day after the use, we have a telemetry document. Once that user syncs through their regular use of the app, a telemetry document will not trigger a sync. But if they use the app to make a form, or they hit sync, or they wait long enough, now the telemetry document will replicate to the server. Now it's the first copy, or the second copy of it now exists in the server. At 2 a.m., that telemetry document will be copied to a second place in the server. So now there are 3 copies of this data. And then when Couch to PG runs, there will be a 4th copy of it created in Couch to PG in Postgres, and now you can access it. And so this is sort of the most common or a common question that we get around telemetry and how telemetry works is you should expect to see a telemetry document appear in Postgres no sooner than 2 days after they have synced their device, the day after they have used the CHT. It's a little weird. It's a big mouthful. Hopefully you never need to worry about this and you're looking far enough in the past, but lots of times people are kind of wanting a bit of a real-time telemetry experience, and our telemetry system is not real-time. Best case, we're looking at 2 days.
All right, before we move to the next section, does anyone have any question?
I think we can discuss later as well, because there are certain interventions that we need the geolocation data. And as per Brian, it seems like there are issues with the CHT core, and how do we, because times we recently completed one of the RCT, and there was the case where we need the geolocation for the ICT. And so far, my understanding at the moment is we may not be able to capture the geolocation, at least for those clusters that we defined during the program design. If anybody else has the same thoughts, or maybe my understanding is going on the other way, we can discuss further later on as well. But yeah, that's my thought.
All right, thank you for bringing that up, Sanjay. Next would be Gocha's performance outliers?
Yeah, great. So if you're going to use the telemetry system records a lot of performance metrics. And if you're going to use the telemetry system to look at performance metrics, there are two really important things that you should know before you start, because it's going to impact your approach and sort of what you're going to expect to get out of the system. So the first thing is that if a device sleeps or if the app moves to the background, then the loading will stop in a lot of cases, but the telemetry performance measurement will not stop. This will give you some really extreme outliers in a lot of cases, like it took 6 days to save this form. That's probably not true. What probably happened is that they clicked save, they moved to a different app. The CHT kind of didn't get the resources it needed. Quite a bit later, it came back, it restored the app, and then it completed saving. And so, this graph that we have here is showing, load times that exceed 15 minutes. A lot of times we see load times that are 8 hours, 12 hours, 16 hours in the app, in telemetry data. The system has no outlier, protection. And so you need to kind of do that on your own. Basically, particularly if you're going to work with max values, you need to understand this sort of like hole in the data accuracy. And the second thing, we talked about the sum of squared data. You can use sum of squares to reproduce a normal distribution curve. This assumes that all data is normally distributed. I've never seen anyone actually do this, but it is statistically possible to recreate a normal distribution curve. Unfortunately, a lot of the measurements that we're doing, particularly around performance data, most performance data is exponentially distributed, not normally distributed. And so really, it's very limited in what you can do in order to understand the distribution of data in the telemetry system. And so those two things together are really important when you're trying to look at this data. You need to do outlier detection on your own, and there's really not a good way to look at distribution of data. And those things together kind of really limit what you can do when looking at performance data in terms of sort of precision. And you should you can definitely get an idea of how fast things are, but precise calculations are like kind of difficult.
Right. Thank you, Ken. We are almost towards end of the presentation. We are right on time. Thank you all